Thank you, Latika. Let me know if you're able to see my screen.
Yes, Sriram.
Okay. This is such a pleasure to join you all for this year on the Global Azure 2022. Good morning and welcome to the session, Object Detection using Azure Cognitive Services. The way we will be structuring this whole discussion is into 3 parts. The first part will be covering the fundamentals of object detection, what's under the hood, the application examples. And the second part will be touching upon the resources that are available on Azure for object detection, what are the different things that you can do on Azure. And then we'll be moving on to demo, which my colleague Sai Sandeep would be giving you. So let us take a step back to understand the fundamentals. We'll first cover up the fundamentals and then move forward. Say, I call it a prologue, where if you see the images that are present on the screen, the human brain can actually classify these images, say, oh, this is the left one is a dog and the right one is a cat. There's something similar if the machine has to do the task that the name that we can give it is called image classification. We will see under the hood section how neural networks or the convolutional neural networks can work in this fashion. And moving on, so let's assume if you have an image of say a dog and a cat in the single image. So previously we were able to give a label like, oh, this is a dog and this is a cat, but here both the animals are in the same image. So what do? We can give a label like, okay, this is an image of a cat and a dog. So we have created a new label called cat and dog, but the catch is we will not be able to tell if you're just giving a label that it's a cat and dog. Oh, where is the cat and where is the dog in the image, right? So you will not be able to pinpoint and say the location where this animal or the objects that you're looking for is in the image. So to come up with this concept, they actually have formulated a new concept called image localization, which is nothing but it's trying to say no. It's trying to when there is a single image in a single object in an image, we're not just trying to classify the image. We're also trying to say the position or the location of the image. Just like here you have dog, so you're saying okay, this is the position where the dog is, and then you are also classifying it as a dog. But what if you have multiple objects in the same image, just like what you have here? This is where we'll have to rely on a concept called object detection, where you say, oh, it's not, you're trying to identify the multiple objects that are there in an image, right? So this is the whole concept. If you again to understand what is object detection, you're trying to understand the interest of the objects which are of interest to you on the image. You're trying to come up with not just say okay, is it present or not. You're also trying to understand the position of those images. And we'll see examples and why is it relevant and things like that when we see the application section. And just to summarize what we have covered, the first we have seen classification, which is only saying okay, is it a cat or not? Is it a cat or a dog, or is it cat or not a cat, and things like that. We are not here. We're not concerned on the position of the image. The second part where we covered the classification plus localization, which is object localization. That is, we are trying to even come up with the box that you see here is called a bounding box. Which says that okay, this is the position of the object that you're looking for in the bigger image that you have. Maybe you have leaves, you have grass, multiple things, but this is the object that is of your interest. So this is the position where that object is. And when it comes to object detection, you have multiple objects. You have a dog, cat, and then duck. And each of those classes, if you try to see, there are 2 cat images here, and then both of them are given the same colored bounding box, saying that okay, these 2 belong to the same class. And then you also have other classes like duck and then dog, which are given by green and blue respectively, just to segregate, saying that okay, you have multiple objects that you have identified, not just that it's all of them are of different classes or categories. So a formal definition of object detection is a task of assigning labels and a bounding box to all the objects in the image. So the label is the dog for this, and then this is the bounding box. In the same way, the labels for the cats and the corresponding bounding boxes that you actually have saying, okay, this is a position. Same thing with dog. So just to ensure now, I think I'm pretty sure all of you would have understood what is object detection, and then how in the at least the overview of what object detection is. So let us try to understand what are the concepts that we have covered, what's under the hood, and how is it done. Right? If you see, if you take image classification, we are saying that if you pass the image of the cat to some neural network, we'll say what is a neural network? It's a convolutional neural network, which is a type of artificial neural network which is used in image recognition and processing, and which is specifically designed for processing pixel level data. So what it happens is when you're trying to build a model which is trying to predict whether it is a cat or a dog, either the image is of a cat or a dog, you feed maybe thousands of images of cats and thousands of images of dog to the model, and then the model tries to understand, tries to learn from those images, and the images should be taken from multiple orientations, multiple positions, where the cat multiple positions. So what the neural net, the convolution neural net does is it tries to actually learn the features of a cat. Say this is how a cat's eyes looks like, this is how a cat's ears look like, and things like that. It will actually come up with some features pertaining to cat in the same way as some features pertaining to dog. And when you send a new image for testing whether the model is performing well or is it good enough, what it does is that it will try to see whether the image, the features that are available on the image resemble or are more closer to the features of a cat, or is it more closer to features of a dog. So it is based on that. A convolutional neural network says that, okay, is it the image that you have sent, is it a cat or a dog? The same can be applied to any other scenarios, maybe for any other images. And we are just taking the examples of cat and dog for representative purposes to make it more simpler to understand. And coming to object localization, you have here we are actually trying to say even the position, not just the label that it is a cat, but you're also trying to give the position of that cat, right? So for that sake, we'll also be sending the positions when we're actually training the model, we're sending the data to the models. We also will be sending the position of the cat in the image. Let's assume in this image the cat is here, maybe in some other image the cat is here. So we'll also send positions of those images, positions of the objects in an image, also to the convolutional neural network, so that it learns that, okay, the position that the objects that I'm looking for is in a specific location, and then it will go that and then try to learn features from that. And because you're feeding all of that to convolutional neural network, the output that you actually get can be a class of it can be the probability of a cat and dog. In addition to that, it will also have the coordinates saying that the bounding box coordinates, say x1, x2, y1, y2, and things like that. So a point to note here, that there are two ways that normally people use creating these bounding boxes. When you're sending it for training or even for inference, once you get the result from the model, how do you use that? The first way is x1. You have x1, y1, which is the upper topmost left corner, and then you have x2, y2, which is the bottom right corner. So the model gives you these 2 points, this point and this point, so that you will be able to come up with this bounding box based on that. The other way to actually look at it is, say you actually give the coordinates of one of the points, and then you give the height, and then the width of it, so that you'll still be able to come up with a bounding box. So this is on the object localization side. Now let us try to understand how we can do this when there are multiple objects in an image. There are multiple approaches for this, and each of them are unique in their own way with pros and cons. The first, which is a natural extension, is the sliding windows, which is consider this image. Say this is the image you're actually sending, and then the neural networks has to learn So let's say dog is the object that we're looking for. At the time of training or at the time of learning the features, or even at the time of inference, that is at the time of testing whether is there an image or is there an object dog in the image. The way it does is that, say, it will try to it will create a kernel, or it will create a grid where you're saying maybe it's a 10 cross 10 grid, and then you're trying to pass from this. You will start from this position, and then it will see, okay, is there some features that are available which are corresponding to a dog, and then it will slightly move to the left. As it's a sliding window, it will try to create one more box here, and then see if there is something available, features which are similar to a dog, and it will try to come up with that. And then you would move it from the left to right. Say let's assume you create a bounding box here, here, and things like that, and then you actually try to process each of those. Yeah.
Sriram, we can't see your presentation. Can you share again?
Is it from the beginning or?
No, just now.
Okay. Are you able to see it now?
Yes.
Yeah. Okay. So just to let you know, the slide window you're saying we'll start off with maybe a grid which is like a grid or kernel which is of n cross and maybe 10 cross 10 dimension, which is just a subset of this. Maybe if this image is say 1000 cross 1000 image, 1024 cross 1024, you have a 10 cross 10 window that you're actually creating, and then you're sliding that window from left to right and then top to bottom. So for each of those 10 cross 10s, you'll actually get a subset of this image, and then you will see is there any features that are pertaining to a dog. And say you will also move it here, and then maybe you will still not get it, and then you will move it here. Maybe some features of eyes and maybe nose of dog is something that maybe the model is able to detect, and then you'll also pass it horizontally from left to right, and then also from vertically from top to bottom. So you'll have numerous such sub images that will get that you will have to work with to understand whether the object is existing, the object that you're looking for is existing in the image or not. So that the potential challenges here, you need a lot of computation because you are processing a lot of images, and if you're moving at a pixel at each pixel level and then trying to come up with a sliding window, then you will have maybe lakhs of images that you need to process. And then many bounding box again, because, and one more challenge is that say you may come up with say multiple bounding boxes. Maybe this can be one bounding box, and then this can be one bounding box. This can be a bounding box, or the best thing, this can be one more bounding box. So you'll have multiple bounding boxes. You also need to decide which bounding box would be the best to even represent the position correctly of the dog. So people have moved on to region-based networks. The region-based network is slightly is definitely better than the sliding windows, where instead of processing the lakhs of images, we use a selective algorithm, selective search algorithm, which selects rather than processing it, creating a window and then coming up with say lakhs of images. The algorithm will actually pick up the most probable cases where you will actually be finding the images based on the image, and then it will come up with somewhere around some 2000. It's called the region proposals. 2000 region proposals. It will come up and then give the subset of the image, and then we just need to look into those 2000 images to say, okay, is there any object that is available that is of interest to us? And again, potential problems, they're still slow, and then it is just a complicated two-step process because you first need to identify, you need to come up with this 2000 images, and post the 2000 images, you still need to come up and then process and then see if there is an object in those 2000 images. So this is definitely better than sliding window, but it is I would say still a little cumbersome. So people have come up with something called this is one of the state-of-the-art algorithms, which is YOLO. That is, you look only once. So here what happens is that you actually the entire image is actually segregated into multiple grids. Maybe an S-process grid, which is a entire image is split into the S-process grid, and then you're trying to come up with say each cell that you actually see here is responsible for prediction of is there any feature that is there. Is there any feature pertaining to this to the objects that we're looking for available on that cell? Not only that, it is also responsible for coming up with say a bounding box based on those features. Say let's remember is there is a contribution to the bounding box coming from those cell, and in addition to that, it will also have something called probability class map, which is say if you see the images the image of dog here, and then it's trying to say okay, it is able to say okay, it is the features of dog that I observe in this cell, so I'll give a color of blue, and then similarly all the cells which are actually more closer to having the features of a dog will actually come up with a blue color. So you again, once you have that grid, what will happen is say you actually come up with this class probabilities, and then you see, okay, all of these actually are coming out as blue. That means this is a position where the dog or the image of the dog could be, right? The same way you have it for the cycle, you also have it for a car here, and maybe some other things. But again, the good part with this is that you actually have the bounding boxes created based on the responsibility at a cell level, at the cell level in the grid, saying, okay, it is contributing to that bounding box of a dog or not. And then you also have the confidence saying that you will get, okay, the confidence that this portion that I'm actually marking it as a dog is maybe 90%, 95%, and things like that. It will also come up with the confidence. But the features here, I think this is one of the fastest algorithms when it comes to object detection. It supports both the real-time object detection. This is one of the very few algorithms which supports a real-time case. Most of the object detection models take long time, at least, to process these images and then give accuracies. And there are some algorithms which are which provide better accuracies with respect to the results, but most of them cannot be used in real time because they require a very high computational time. But this is something that maybe there's a slight hit on accuracy with respect to the best that are available, but this is the fastest. So most of the times you would see this getting implemented in the enterprise when you have any real-time scenarios. And we will see some examples here too. The application of object detection. Yeah, you would have seen some maybe YouTube videos, or you may have seen some posts on LinkedIn and things like that, where someone posting saying that, okay, oh, we have built a model to detect objects. Maybe you have a pedestrian, you have cars in this image. So all of those, as I was saying, irrespective of the number of images that are available, they're not very close enough. Then you will be able to detect the objects. It can be used in the counting of persons who are entering a mall, or it can be counting of the number of vehicles entering a parking garage. All of those can be the use cases. In terms of lane detection, this object detection concept is also used in self-autonomous cars, where you actually understand the terrain of the road and then see, okay, the markers of, okay, where is the divider and things like that, and then see also the specific objects that are there that are there when the self-driven car is actually driving on its own. So even in the lane detection, and then a lot on self-driven cars, these concepts are used. Face detection, you have images, and then you want to see how many people are there in the image, and maybe extension. Maybe not extension of this is also, once you detect, you can also have recognition of those faces, saying that, okay, is it a recognition of face recognition of a celebrity and things like that. But you predominantly used in how many people are there in the image, and trying to come up with the position of where the face of a person is in the image and things like that. A lot used in maybe the latest mobile phones, the detection of the face. Then it says that you are actually smiling and things like that. So all of those, the similar concepts are used when someone is actually saying that the mobile, you can actually take a picture when you smile it and things like that. So concepts of this are embedded into that. Same with brand logo detection. You can detect the brand logo with respect to the position. And the best thing with object detection, it is position invariant. That is, when I say position invariant, as it is using a convolution neural network at the backend. It is not required that the Coca-Cola should be in a straight line, only then will it detect it. It can be tilted like this. It can be, if the bottle is like this, it will still be able to detect it, because it's using convolution neural networks at the backend. The same thing on this is a very widely used application where license plate, if you're jumping signals, and then cameras that are capturing the image, it can also detect the number plate on the car, and then that's how your real-time monitoring, and then coming up with some fines that you see in some of the places, even in Hyderabad and even in India. There are other organizations who are also focused on building models using object detection to detect these license plates on images, and then they're also serving the police in maintaining the proper decorum in the traffic. And this is one of the use cases where we have implemented it for an Indian life insurance carrier, where as per Supreme Court guidelines, if someone is capturing the images of Aadhaar card, they are supposed to mask the first 8 digits of the Aadhaar card, and then before the advent of this AI solutions, I think they were all using a bunch of some 20-25 people who are opening Microsoft Paint and then manually doing it. But now with the solutions, the AI solutions that we have also built for that carrier, we were able to identify whether the document is an Aadhaar card or not, and then post identification or post classification, we were also masking that Aadhaar number because we were considering the Aadhaar number as an object, and then we are trying to go and then mask it. On to why object detection is harder, because there's a much larger impact of the post. So let's say if you see if all the images of the hearts that you actually have in your training set is something like say, standing and things like that, and then this is the position of the pose of the animal when it is lying down or when it is sitting, and then if those images are not available and there are no features of maybe eyes or nose that are learned by the models available here, it may not be able to detect it. And occultation is one more major challenge where you see there are two persons here, but one almost intersecting a lot as an object. This object is intersecting with this object, and it's very tough even for humans to just give me a second. Yeah, so it's very tough for the humans to also understand that unless I say there are two people here, it's very tough. So even for the object detection, it is going to be tougher to come up with say creating a position of and a bounding box for these two men, which are very close intersected objects which are intersected. And also a case where you have smaller objects. If the size of the objects are very small, it is really tough. Say let's say you want to try to come up with say some wind that you want to come up and then say maybe this is very small image in this entire big image. So the smaller objects, it is really tough also to make a detection because the models are not equipped on that. And let us look into what are the options that we have with respect to object detection on Azure, and how do we create it? From the resourcing standpoint, you actually have custom vision resources that are available on Azure, which are specifically for the purpose of custom vision service, which can be used for creating a training resource or a prediction resource for object detection. At a broad level, you can also select maybe a cognitive service resource which includes this custom vision and then a lot of other cognitive services that you can leverage. So you can create a cognitive service resource, and then you can be using that for training or prediction or for both. Or you say, I just want to use the infrastructure of Azure and not much of the model creation. I don't want to do it on Azure, and then you already have a pre-built built model on your on-premise systems. You can even bring in your own model into Azure. You can deploy that. You can register that model into container registry, and then use Azure DevOps to create the CI/CD pipelines and then make your predictions. And if you're someone very familiar with AutoML in Azure, I think that object detection models are also part of it, but it is in preview. And then if you have an organizational account or enterprise account, you can ask Microsoft to give access to those, and then you can explore that. And it is also promising. Into the custom vision, my colleague would be giving much details into this, but just for your understanding, it would be you'd be uploading the images, and then you'd be training. You'd be performing some training activity to train the model, and then post the training is done, you would be evaluating the models. Sandeep would be showing you this whole process. And looking at the object detection on Azure, if you take this image as an example, and then the image that you would actually be getting is something like say, there is a kitchen utensil, and then you have a confluence of this, and then you have X and Y coordinates, and then the height and width of it. This is the second option, that second way of defining a bounding box. And in the same way, you can have a computer keyboard, and then what is the confluence that it is a computer keyboard, and then the corresponding bounding box, and then you have multiple other objects that you can actually get as a laptop, and then person which is 85% and things like that. And limitations on Azure is predominantly the similar limitations that are available with object detection are also applicable on Azure. If their images are very small, if it is less than 5% of the image, normally that will not get detected. If they're very closely stacked together, just like you have appellation, as I was saying, I think if it's very closely stacked together, like a stack of plates, individually you will not be able to come up with, say, what is the object in the position for that. And then especially if you have, say, two different brands of same product. So let's say we have soda bottle from Kinley and then soda bottle from some other distillery. Let's say if both of them are similar, and then if your use case is to say I want to distinguish those two similar looking objects, that will not work. But however, you will still be able to extract the brand information. Say let's say you have Kinley and then distillery, you will be able to extract. If that is the object that you're looking for, then you'll be able to extract that. But you'll not be able to differentiate, saying that you may still get bounding boxes, and it may be the same bounding box that you may get as classified as bottle, but you will not be able to segregate two different bottles. And now my colleague Sandeep would actually take over, and then he would be showing you the demo of the topics that we've discussed. He would be covering the computer vision, the custom vision, and then also the cognitive service thing. Yeah, over to you, Sandeep.
Hey, thank you so much, Sriram. And yeah. So yeah, myself Sandeep Karni, working in ValueMomentum team. So yeah, this is the Azure home portal. You can see all services like computer vision, cognitive services, some container registries, connections, and along with some subscriptions as well. We'll go and look for custom vision. Just click on it. And we go ahead and select custom vision, and this is under cognitive services, as you can see. Now let's go and create a custom vision resource. While we are creating this resource, we need to specify some details as well. So for example, what is the subscription you are making use of, and and which resource group you are selecting. And if no resource group available for you, you have to create it for your own. And also we have to specify the region and just give a name to it. And now let's go and select the pricing types as well for the training and as well as prediction. If you see, we have selected both. That means basically we are saying that we want two resources. One is for prediction, the other one is for training. Now we will go and check whether the custom vision resource is created properly or not. So if it is properly created, you can see this custom vision name, and this will be under resource group. As you can see, custom vision is a name I provided, and this is under resource group. And you can also see the subscription I provided and the location I specified. Now let's go ahead and understand how do we build an object detection problem using custom vision service. This is the custom vision portal, the project portal, and we are going to solve object detection problem. Now you can also see the project name, project type, resource, such filters are there. And let's go ahead and create a new project. For that, you also need to specify some of the details. Give a name to this project, add some description to this project, and you have to pick one of the resource from the drop down list. If no resource available for you, just go and create a new resource. And you have to select the project type as well. In my case, this is an object detection problem. I'm selecting it. And these are the domains. You can see these are the neural networks which are trained by the Azure. And so we can go ahead and make use either of general or any logo or any product on shelves or any of these. If you are unsure about what domain to select, just you can go with the general because it includes everything. So this is the project which I already trained a short ago, and I named it as an object detection, and the resource name is IMG Classy. So I'm just clicking on it. This is the Azure portal training images section. So go to the Untitled section, click on add images in order to add all the data sets that we have. Once we add the images, we will go ahead and label the images manually. So all these labeled images are being under tagged. That means these are the tagged images which I already tagged. That means I already labeled with some names. You can see. So we go ahead and once the tagging is done, we can just go ahead and click on train. You can see there are two sections of training. One is quick train. The other one is advanced training. If you click on quick training, this will give you the quickest results. If you want to select the advanced training, you wanted to, select longer period of time, you can go ahead and select the time and adjust the timings. And this will also reflect the budget as well. So your model can learn better from the data sets. This is how you can train the images. In order to train your model or in order to train your images perfectly, it always depends on the visual variety. For example, let's say there is a camera angle and lighting, and also it depends on the background, visual style, and whether the image is a single subject or grouped subject, and it is also depends on the size and type. While adding these images, you can make sure the size of the image should be less than 6 MB and not more than and also not less than 256 pixels in the shortest edge. So if you upload a less pixels of the image, this will automatically, the Azure will automatically select, scaled up by the custom vision service. So we can go and select quick training already, so that this is the performance tab. These are the final results or the performance of the model. And now the model is, ready to publish. Now we will go and publish the model. So for publishing the model, you have to give a name to it. So this will, later utilized by the SDK Python services. And this is very much important for the Python SDK. Okay, this is the published model. I named it as the model name as detect food. And this is the precision, recall, and the map are the output results. As you can see, this is the probability threshold slider. This tells the level of confidence that your prediction needs to have in order to get the considered results. And also we have overlap threshold. This means that it deals with the how correct an object prediction must be to be considered correct in training. And the optimal value of prediction result is 50%, or you can say it's 0.5%. And if you see over here, you can track multiple iterations of the model that you can build. As you can improve the model, you can give different iterations, and whenever you want to predict, you can specify which iteration you want to make use of in order to do the predictions. So now I will go and test the image quickly to see how the model is performing. As you can see, you can upload image by the URL, or you can browse the image local. This is how you can test your image in the web portal. And you can also change the iterations. It is under now iteration 3. You can also go to the iteration 2 and iteration 1 as well, because I have only 3 iterations. Now let's go ahead and implement Custom Vision SDK using Azure API credentials. In order to implement that, we should check where the resources are exactly published. As you can see, you have to go to the settings icon and see what is the project name here, and what is the project ID, and which resource it is belonging to, and what is the key, and what is the endpoint. These are very important. Now I'm going to my Jupyter notebook. This is my Jupyter notebook, and I paste all the required keys, endpoints, and project IDs here. As you can see, this is the project ID, this is the custom vision key, and this is the endpoint. I pasted it here from the settings. And most important thing, this is the model name I given while publishing my iteration. And this is under iteration 1. And imported required libraries is one of the thing, and you have to install the cognitive services from the pick. And these are the required libraries I imported. And if we see in this particular code, we have connected to the custom vision prediction client. This is the custom vision prediction client in order to get the predictions. And we are making use of API credentials. And as you see here, we are also using the image draw to draw the rectangular box. We call it as a bound box to detect the images in the image section. I use NumPy operations for the numeric operations, and also I get the directory and I load the test image, and I specified the location. And in order to get a prediction client for the object detection model, you have to use the prediction key under the API credentials, and also endpoint under the custom vision prediction client. I'm taking it as a predictor. Now you can detect the objects in the test image with opening the image. And also you have to create a figure to display the results. Once you create a figure, and you can also give the object color, line width, and you can also draw the image with the help of the rectangular shape. Now I given pizza in purple color and cold drink is a black color, which are 2 labels I have created before. And now I'm in here the prediction results, where you can see using the coordinates like left, top, height, width to finding the objects in the image. So once we get all these details, we make use of those coordinates in order to draw a rectangular box with the detect image. Now let's look at the outputs. This is the output, and you can see this is a cold drink. The model predicted pretty much that this is a cold drink at 99.38%. And when you look at the pizza as well, the pizza is 99.51%. Let's look at another output. And this is the cold drink. It's pretty much and very accurate. It's 99.91%. The model detected very well. And let's jump to another output, the final output. Yeah. And this is the pizza, and it is also, accurately predicted 99.69%, and this is a cold drink 99.98%. That means we are very close to the 100 because predictions are never been 100% accurate. And this is very much about the code, and you can see how simply the code is and how easily we went and implemented. Hence, we can make use of user interface custom vision user interface, or else you can also make use of SDK to go ahead and train your model. So that's pretty much from my side. I hope you all enjoyed it, and thank you very much.
Any questions? We'll be
Thanks, Sai. Yes, Sriram, I'll read it for you. So the first question is, how long prediction images are stored?
So I think there'll be again. Normally these images are stored into Azure Data Lake. So you can again, the retention period is something that you can define. You can, if you wanna discard it after a certain period of time. Those things with respect to object detection, if you're using there are two ways to look at it. Say those images are if you're using it as an API as a service from Azure, that would be stored from their side, but you can request them to actually not store it from your end. If you have, again, based on your enterprise agreements that you have, you can request them and then they will not store your images. If you're if you're using the SDK and then you're trying to do things from your end, it will be on. You can write a separate script to also delete the images which are there on your data lake or wherever you're storing it from.
Thanks, Sriram. Next question is, how convolution neural network can be used in insurance industry?
Okay. Yeah, it's a good question. I think the plethora of use cases. Again, one example that I was saying of the Aadhaar masking and things like that, where you are able to again at the back end of object detection is again convolution, right? So in the Aadhaar masking, we were actually we are using convolution neural networks at the back end, trying to identify where that object that we're looking for, and then we're in the Indian context, that is a beautiful use case of trying to automate that whole process of manual effort. The same way you will have, say, maybe cases where you can try to detect the car images and then say if there are any damage in the cars. I think there are some specialized players who are also detecting Claim Genius is one company where they use numerous they use CNNs and then multiple other CNN related frameworks, and then they try to detect based on the image of the car. Let's assume there is an accident, and then based on the image they say what is the estimated amount of damage, and then what should be the payment for the claims and things like that. So there are multiple plethora of use cases on the claims and then also on the processing side of things, policy processing or court.
The next question is, it's quite interesting, how drones with AI-powered object detection can cut down inspections cost in the insurance industry.
This is a beautiful question. Actually, we are working with one of the Fortune 500 companies where we are working on the aerial imagery part of it, especially on home insurance, where this is predominantly on the US side, where there are aerial imagery, be it drones or be it even from the satellite imagery. There are images that are actually that would get captured, and then this object detection models can detect. Is the rooftop of the home damaged? Is the rooftop of the home damaged? Or you can even detect, say, based on that, is there any swimming pool for this, or is the car or vehicles being parked outside? There is no shed, or there is no shed where there is the car getting parked, but the vehicles are getting parked outside. How many trampoline? How many poles are there? You can even the vicinity of you can even detect if you are having a objects being considered as swimming pools or poles, and then cars and things like that. You will get to know how you'll get to know multiple things, and you will also bump into cases where the person is not specifying that there is a swimming pool in the house outside of the house and things like that, And then if the image captures that, it will also give it saying that okay, a flag saying that okay, there is also an object swimming pool available in the image. So it's a beautiful case. There are multiple opportunities, I would say, even on the aerial side when it comes to using object detection, aerial images and things like that, and then even the drone images. And it will cut down cost because especially when it will also cut down cost where if you have adjusters who have to go to the top of the roof and then see how much is it damaged and things like that. Or there are more cases where adjusters also fall and slip and fall and things like that. So all of those you can avoid the additional costs that the companies will incur, and then you can at the time of not just on the adjuster side, it will also save a lot of costs when it comes to underwriting the policies or renewals. Or should it be underwritten, or should we even before we issue a policy, we have to ensure that it is of some standard is maintained, the rooftops and things like that. And then if it is a renewal, you'll also have cases where before renewal, you definitely ask your person, ask the insurers a person to go and then see and then ensure that it will not become a very bad claim. Or you do some damage control, or you try to do some prevention, risk prevention there. It's a beautiful, again, I don't know who has asked this question, but it's a beautiful question. Yeah.
Yeah. So next question is, how do we calculate the precision for the object detected? Are there any algorithms involved in this process?
Yeah, I think you'll calculate the mean average precision. That is one of the metric that you calculate for object detection. But I think many of the Python libraries support that. So again, even for the again, there are libraries that are available which can be used for this, but they're pretty standard. I don't see it as a challenge. You'll have normal libraries of object detection serving that purpose. Anything that you want to add, Sandeep, on this? Or?
So the next question is, what is the maximum iterations can possible to train the model?
Okay. Object detection models, again, it depends also on the number of images that you have, and then again, I would say typically at least 100. Again, depends on the volume of data that you also have. Say, I don't see anything less than 50 getting converged, and then you'll have some great results. Again, less than 30, I don't even see, but normally somewhere around 50. And then if you have very huge data sets, and then you wanna make it as close as possible, then maybe you can go up to 100 and more than that. But normally at least 50. 30 is the minimum. Without 30, I have never seen getting great results less than with 30 iterations. But yeah, at least 50.
Thanks, Sriram. The next question is, looks like people really like the session. When we train for cognition, does it also keep the background info handy to avoid any abnormalities or change?
So, can you come again, please?
Yeah. When we train for cognition, does it also keep the background info handy to avoid any abnormalities or change?
I think that is a task from the data science team. I don't think Azure or any of the commercial services that would be available, they would be doing that. In fact, maybe again the aerial imagery use case that I was saying for the rooftop, I think it should be we who should be trying to I'd say unwanted portions of the image is something that you're gonna again again, I'll not say blur as a blur, but maybe you're trying to mark it as some black or something like that, so that you'll have portions which you are looking for, which you're looking for or which you're interested in, and it is not there are not it should be on the data science team who will be working on that. There is no commercial services who will do that because they don't know what you're looking for as an object, right?
We have one more question. Why same image set with multiple iterations produced different prediction accuracy?
Sorry, come again.
Why same image sets with multiple iterations produced different prediction accuracy?
You want to take that, Sandeep? Or?
Yeah. So we cannot take same image sets again and again and passing through that training model that will give you the inappropriate results, I can say. So to avoid.
No, okay, I think the question is more from the standpoint of, say, when you're using a similar or same data sets, you're still getting different results from maybe from different iterations. The reason is that, say, it is not like, say, if you're using a traditional machine learning, you'd use something like a random seed and things like that, right? So it did not be of that sort when you're doing neural networks. Say you would get very close. You may not get the exact scores each time for the same images with different iterations, because you are actually maybe because of the way that neural networks works, right? So let's say if you have batches, and then you may also be using some dropouts, and you may be using some, again, it's the way that you design the architecture of the framework. So and also it is also randomly picking up some of the images, and then it is also changing the parameters of the models and things like that, which are which are dependent on the data sets, underlying data sets. So in each of the iterations, maybe it is not picking up the exact same images every time, or other things like, say, maybe the random dropouts that might be there that are implemented that may change to some extent slight deviations in the accuracy or the precisions that you're actually making, that you see in the metrics. So that is also the reason most of the times in these cases you actually go with the mean and average precision rather than going with just a normal precision. You take MAP, which is mean average precision.
One more question. Are content tags and object detection both same?
No, okay. This is again this is a really good question, because the content tag is more to do with, say, trying to give just the contents in the image. It is saying that, okay, it's something like, say, if you have an image, it will say that, okay, there is a dog, there is a cat, there is duck and things like that. But the content tag will not give you the position of the image. Vis-a-vis the object detection is something that will give you also the position of the image in addition to the object labels and the confidence. The content tag will just give you the tags. It is something like, say, you're trying to tag an image saying that, okay, there is a dog, cat, and then maybe a human or person in this image, so that maybe it will help you in efficient when you're searching out for images which are having dogs, cats, and then humans in the same image. Maybe it will help you in efficiently searching and things like that, but it will never give you in the image where is the person or where is the dog and position. No, it will not give the location or position. But object detection will do that. Yeah.
Thanks, Sriram. Looks like we have covered quite a bunch of questions for this session. Thanks for sharing your deep study and knowledge about object detection using Azure Cognitive Services. Thanks, Sai, for giving a great live demo on the topic. Now, it's time for lunch.